Hi, my name is Matt Ruark. I'm a professor at the University of Wisconsin-Madison and also an extension specialist with the Division of Extension. This presentation is going to be on quantifying the benefits of legume cover crops following winter wheat. I'd like to thank my co-authors, Chelsea Zegler, Jamie West, and Mike Ballwood. So the main thing when we talk about cover crops is, well, what's their potential benefit for crop production? So a lot of the cover crops that we promote are for conservation purposes, like the grass cover crops. But as we see in this review paper that evaluated the effect of using a grass cover crop on corn yield, so that would be the next, this would be the corn yield following the cover crop, we see that we tend to have most of the data skews slightly negative, implying that we're seeing lower yields following a grass cover crop. But there's certainly benefits to using that grass cover crop for erosion control. It grows quickly, as well as trapping some nitrogen and preventing some nitrate leaching. On the flip side, or as an alternative, we can use legume cover crops. Now, legume cover crops, we have a low C/N ratio, so they're pretty nitrogen rich. So when they decompose, they supply nitrogen to that next cash crop. And so those, sometimes we refer to that as green manures. Based on this literature review, you can see most of the data in the literature skews positive, implying that corn that follows a legume cover crop tends to have higher yields than following no cover crop. So legumes, it's possible for them to have that dual benefit of supplying nitrogen and helping improve crop yield. Another recent meta-analysis showed on the right here for crop yields, the legume cover crops skewed positive, 20% increase on average in crop yield following a legume cover crop, while the non-legumes had a neutral to negative effect. Although on the nitrogen leaching side, that's the big benefit of the grass cover crops is for nitrate leaching. Okay, so the question then becomes, well, okay, legume cover crops are pretty great, pretty well quantified that they have these benefits. So how can we get more legume cover crops planted? Well, the problem with the legumes is they take a lot longer to get going and established. So I would say I've broken this into sort of three categories of where they would fit in. It's easy to get legume cover crops planted if we frost seed into winter wheat or plant after a winter wheat harvest in the summer. So it's possible to get legumes established and going if we interseed them into corn. That works ongoing, and certainly more difficult to get them planted after corn or soybean to get that kind of establishment you need. So this presentation today will focus on the easy stuff. If you have winter wheat in rotation, if you have some other small grains, if you have any crop that's coming off in the summer where you'd still have plenty of time for a legume cover crop to get established and put on a fair amount of biomass, that's where we're going to have the biggest benefit. So I'm going to talk about two things. One is frost seeding into winter wheat and talk about that process and show some study results. And then also testing some other legume cover crops that can be planted following winter wheat. So all the work that's presented here has been funded by the Wisconsin Fertilizer Research Council. So we thank them for their funding. So let's start with frost seeding red clover. So this is a picture in a field in the fall following, this is a few months after a winter wheat harvest. So you can see one of the benefits right away is we have a nice establishment of the red clover, a nice thick stand, and where we have harvested winter wheat, we see that we do have a lot of volunteer winter wheat come up. So this is a system where you're going to plant the wheat in the fall, the previous fall, and you're going to come out in the spring, early spring. We're looking for conditions like this. These are perfect conditions. Late May, maybe even into early April. The snow's off the ground, the soil's pretty dry, and that you can get on it. So here we're just gonna overseed this red clover seed onto the winter wheat field. And so here's another picture you can see. So the winter wheat is not really started to take off yet, but these are good soil conditions to get it planted. And this is also the crop previous to that was soybeans, so we don't have a lot of residue covering the soil. So when we seed, we are still getting that good seed soil contact. And even better, if you have a little bit of cracking in that soil, that'll help that seed soil contact. So as that soil kind of wets up, it'll help with a little bit of that shrink swell, help improve that contact with the soil. So these are the perfect conditions to do this in. Then what's going to happen is you're going to, the winter wheat's going to take off. The clover then will also start to grow, and it'll just hang out in the understory. So that's the nice thing that I like about the red clover. It doesn't try to do too much. All right, it'll get out of the ground, but that wheat kind of has that nice canopy. It will have that canopy closure, and it doesn't try to overachieve. So it'll just hang out until that wheat is harvested. Then when it is, boom, it's already established, and then it takes off. So the value of the frost seeding is you're basically getting that jump start on the growing season. So here's a picture of a nice field that was planted in October, where we have a nice thick stand of red clover that was grown. And then again, compared to the amount of volunteer winter wheat that can happen in these other plots. So I will say one more thing about this. In this system we have set up is that we're growing so much biomass that we're actually mowing this back at least once to prevent, a lot of disease from taking hold. And we are going ahead and we're going to terminate this in the fall. So we're going to terminate this in the fall. We've grown enough biomass. We're going to terminate it in sometime in October, where we feel we don't have to worry about letting it grow into the spring. Certainly if we let it grow into that next spring, we could terminate it again. We could grow even more nitrogen, so to speak. But here we're hedging our bet a little bit. We're going to terminate in the fall, so we don't have to worry about operations in the field in the spring. So then what we're going to do, just like any study that I do, is we're going to follow into that next corn crop, and we're going to conduct a nitrogen rate study. So this is the first work here is from Janesville in 2010. This is work by Jim Studi and Kevin Shelley. And they conducted a nitrogen rate study. So on the x-axis is nitrogen rate, and the y-axis is corn yield. So in the red dots are the corn yields following no cover crop. In the blue are the corn yields following a red clover cover crop. So when we do this plateau analysis, basically where does the yield start to level off at, right? And the point where it starts to level off at is the optimum nitrogen rate for that site. So the first thing we see is we're seeing this yield increase. So we're seeing 25 bushel plus yield bump just from following that red clover. And we're seeing where these yields plateau. You can see with the red clover, we're maximizing yield with a lot less nitrogen compared to no cover crop. So when we use a linear plateau model, we've shown that we can get a nitrogen credit of 46. We use a couple different models. We actually saw a range of 41 to 82 pounds based on the statistics, but we do based on this, we're saying 46 pounds. So in general, we we throw out that 40-pound nitrogen credit if you use a legume cover crop. For the longest time, this was really the only data we had to go off of. So we've continued some of this work at our Arlington research station just north of Madison. We saw some interesting effects. So in 2016, again, this is following a red clover cover crop in blue, no cover crop in the red. Slight twist on this, we actually saw a slight yield decrease, a little bit maybe more than slight, in these high yielding environments. So there was nothing, and we maximized with 16 bushels less following red clover. Not clear why this was. There was no indication in season that these crops were stressed at all. You can see that we're seeing, great yields here. So there's something in there that prevented that. We have to a little more investigation to figure that out. But what is clear though is you can see, especially like down here where we're seeing much greater yields with no nitrogen applied, that red clover is supplying nitrogen. Based on these response curves, we say 92 pounds of nitrogen is what it supplied. So we're growing a lot of nitrogen and we're seeing this big benefit. But this is concerning. We don't really know what's causing this yield drag. We conducted this again. We skipped a year, came back in 2018. We added an extra treatment in here. And so this is in the blue here is following a no cover crop. So we're seeing that same thing where we see lower yields with lower nitrogen rates in that no cover crop. We also had in the orange here, the nitrogen response found in the red clover cover crop. And we added an extra treatment here in the gray. We actually had other plots where we harvested that red clover biomass. We say, well, what if we needed a little extra forage and we need to take that off? So two things here. Well, let's start with this. One is we did see a little bit of a yield drag again, 8 to 9 bushels. So there was something else happening at this site. Again, nothing that was clear in season that would suggest that would have been set back. But we are seeing about a 30 to 40 pound nitrogen credit. So yields are maximized with a lot less nitrogen compared to without a red clover. So certainly it's supplying some nitrogen. You could cut back on your nitrogen rates. The other thing that's interesting is that we're not seeing a difference between the red clover, where the entire biomass was returned to the soil, and the harvested treatment, which means the above ground biomass was removed, but all the root biomass stayed. So this would give us some indication that it's actually that root biomass that's supplying the majority of the nitrogen. The above ground biomass may not matter as much. So kind of an interesting effect that we certainly need to study more. So, we always think about the stuff we can see. We want to produce a lot of above ground biomass, that's for sure, but there is still a lot of nitrogen in the roots below ground that's decomposing and returning nitrogen to the soil. So some positive aspects to this, certainly. Clearly, and every time we've done this, we've seen that red clover supply nitrogen, good amounts of nitrogen. Sometimes we're seeing this slight yield decrease. Unclear what that effect's all about. So that's one option. The problem with another drawback to it is that you got to get out and get that frost seeding happening at that right time and good conditions. There's a window, all right? And if you miss it, then what do you do? Well, I suppose the good news is that there's still, you have the option of drill seeding legumes in after a winter wheat harvest. So the ones that we've tested are berseem clover and crimson clover. So the trade-off with this is that you can grow a good amount of nitrogen and biomass with those crops, berseem and crimson, but both of them will winter kill. And so then the benefit to that is that you don't have to go out, terminate in the spring or the fall. Works well in no-till systems. The trade-off is, the question is, are you maximizing the benefit of that legume? Would it be better to have something grow into the spring? Can we get enough biomass to produce a good nitrogen credit? So we conducted work across 3 growing seasons up in northeast Wisconsin, mostly in Sheboygan County, on berseem and crimson clover. So we'll take you through a few pictures and then I'll show you a few years worth of data. So for the berseem clover and the crimson clover, both grew well. Berseem in our trials tended to have a little more consistency with its with the planting establishment. Crimson sometimes had some skips in it, depending on the variation in the field conditions. The berseem tended to grow a little bit taller, a little bit wispier. The crimson clover didn't grow as tall and was a little more dense in its biomass. So we're just seeing some weak spots, but then you have some spots where it did, up in here where it grew really well. Moving on to another year, the berseem crop, again, amazing amount of biomass can be produced with this berseem crop. Grows pretty tall. Another picture with the crimson clover, not too bad with the crimson clover. Just certainly not as tall, but this year was a great year for crimson clover. Nice dense stand. And then when we compare them, you can see that there's a fair amount. We get much taller, a much taller crop with the berseem clover compared to the crimson clover. So it will just look different, even though they might produce somewhat similar amounts of biomass. The big trade-off is that you lack that residue control, enough residue to control erosion in the spring. That said, if you can grow enough biomass, the question is this enough dead biomass coverage for erosion control? Maybe, maybe not. So in some years, it looks pretty good, right? In some years, this is with crimson clover, doesn't look very good. That crimson clover looked like it kind of fell apart pretty easily. Didn't have as much biomass coverage. So if you're looking for biomass coverage, the winter killed legumes aren't going to be the way to go. Every year we always dug them up too. We always had our seed treated with an inoculant. Is that necessary? Not sure, but if we want to really make sure that it's fixing a lot of nitrogen and growing well, that we always invested in that, and we always checked that legume nodules were forming, so it was fixing nitrogen in that biomass. But a quick aside. So the fact that these clovers or legumes fix nitrogen, they have that symbiotic relationship with the soil bacteria, where the bacteria then lives inside those root nodules, and they can convert nitrogen from the atmosphere into usable nitrogen for the plant. The plant then feeds the rhizobia bacteria to keep it alive. So there's that, it's a symbiotic relationship. Now, that helps bring new nitrogen into the system and helps the plant grow and prevents, allows this plant to do well in low nitrogen environments. But the benefit from this nitrogen credit does come from the fact that the seed-end ratio of the biomass is low. So it's about the decomposition patterns of that biomass. So it's a nitrogen-rich crop. It breaks down. When it decomposes, there's a lot of nitrogen left over after that decomposition process that can be available to that next crop. And just always for comparison, we have this, the no cover crop control, where we see, a lot of exposed soil, some volunteer winter wheat coming back. So in 2015, we planted the covers on August 15th. Sorry, the nitrogen rate study was in 15. So in 14, we're setting it up, planting the cover crops August 15th, seeded at both rate about 15 pounds per acre. And then 2015, we plant corn, and then we put out a bunch of nitrogen rates, and we're looking for this effect. So the main conclusion from the first year then was that crimson clover provides a nitrogen credit, and both crimson and berseem clover provide yield benefits. So for crimson clover here, we can see that crimson clover's in red with this red response line. Berseem clovers in green, and I've mixed that up already. The no cover crop control is in red, and this is the response curve. So this would be your standard response curve to nitrogen for corn that didn't follow a cover crop. Then the crimson clover is in blue. So the first thing is we didn't see that big effect for that crimson clover at these lower nitrogen rates, but once we start applying nitrogen, we are seeing this yield bump. And when we look at where these yields start to plateau, we are seeing ultimately a four bushel yield gain, but look how much less nitrogen that it required. So based on this, we're saying 168 pounds of nitrogen. You can maximize yield with 168 less pounds of nitrogen. Now you probably aren't you may not be putting out nitrogen all the way at this level, but that's what that calculation is. So certainly it would indicate that it is supplying nitrogen. And in that year, we only had 46 pounds of nitrogen in that above ground biomass. So when we're doing these calculations, we're collecting the above ground biomass only. So even a fair amount of biomass to grow a fair amount of nitrogen is still producing that benefit. So what about berseem clover? So berseem clover, we grew 75 pounds of nitrogen this year. So we did grow more biomass and more nitrogen. A little bit odder of a response curve but the main thing is to look at, there's a couple things to look at here. Generally always seeing this yield benefit across all the N rates. We saw greater yield. Second is we saw this big bump when we're not applying any nitrogen, this huge yield benefit. So just from this alone is showing that the berseem clover is supplying nitrogen. Exactly how much, we have some estimates based on some other things, but anywhere between 40 to 60 pounds of nitrogen in this case as well. The problem that we saw is that we always struggled with is that, so we always collected pre-plant nitrate tests, not the best way to evaluate these in-season, these legume nitrogen credits. Here we would use a pre-sidedress nitrate test. In any case, following the no cover crop, the crimson and berseem, we never saw that flush of nitrogen from these clovers at the pre-sidedress nitrate test. It wasn't helpful for us. So that was a little bit of a bummer. We do promote that for its use, but it may not be as helpful as we think in these conditions. We continued the study again at a different location. Here, we planted the clovers on August 12th, again at 15 pounds per acre. We also applied P and K to that field as well. It's a little low in P and K. And then we end up sampling about November 5th. So in reality, we get maybe 3 months of growth in these conditions, maybe 2.5 months of growth, depending on when we're sampling. And then the next year we're following with a nitrogen response study. Okay, so we're going to throw this all together. In this year, crimson clover had the clear nitrogen benefit, and berseem had the clear yield benefit. So what I like to do here is just it's the same. The red is the no cover crop, crimson's in blue. Although I suppose we should put crimson in crimson, but and berseem is in green. And then we have these lines represent the yield plateaus. Yields go up to this level. So basically, this line is where the average yield once we stop increasing yield. So no cover crop, we max out at 210 bushel. Crimson clover, following crimson clover, we maximized with 208, but we did see a nitrogen benefit, 46 pounds of nitrogen again. With crimson clover, we saw a bigger yield bump. Here we see 13 bushel yield increase, but a smaller nitrogen credit in this case, only 15 pounds. So that was a little bit variable in terms of the crimson clover produced 70. This was a great year. We had a lot of biomass, 70 pounds of nitrogen in the above ground biomass, 81 pounds nitrogen in the above ground biomass with the berseem clover. So there's a lot of nitrogen we're adding back to the soil. And with the response curves, we can get 40, around that 40 pounds. We got it with crimson. We didn't necessarily get as big of a bump with the berseem, but we are seeing a yield benefit. Okay, so we're getting a lot of mixed results, which can happen. And again, we go back to that pre-sidedress. If anything, it tells us that maybe this site wouldn't have been that responsive. We still had a pretty high high nitrate conditions in the sidedress treatments. In the no cover crop treatments based on a pre-sidedress nitrate test. You can see we see 19.6 as the value in that upper foot. But we're not seeing this big flush of nitrogen being in the crimson and berseem plots when we sample at in early, late May, early June. So when we put all these numbers together, here's what we get. So we have 2 years of red clover data, 2 years of crimson data, 2 years of berseem data. We see this big range, anywhere between 15 to 168. On average, we calculate about a 68 pound nitrogen credit from legume cover crops, regardless of species or when it's planted. But you can see that there is quite a bit of variation. On average, then too, we see anywhere between the 27 bushel yield bump to a 16 bushel decline. On average, we're seeing an 8 bushel yield increase. So in general, we're seeing it be positive, although certainly this doesn't include that second year at Arlington. But we do see in most cases, we see a positive benefit. However, most of that positive benefit does seem to has been shown in the crimson and berseem studies in Sheboygan rather than the frost-seeded studies in Arlington. So I will say these are unofficial numbers. We have a couple more years of data, of years of numbers to crunch, apply some more rigorous statistical approaches to this. But at the end of the day, then, what does this mean? That the legume cover crops do what we think they're going to do. They have that, they add nitrogen. You can cut back on your fertilizer nitrogen when you use them, and it's likely you're going to see a yield benefit with using them. So they apply meaningful amounts of nitrogen to corn when planted after winter wheat. I should really just say when you're able to plant them in August. On average, supplied about 60. Certainly was variable from year to year. I think that then using a book value of 40 is pretty good. Our biggest challenge then is like, what's that assessment to let you know if it's going to be a year where it's probably going to only be 20, or it's going to be that year where it's 60? Is it above ground biomass? Is it a soil test? Is it a tissue test? It doesn't seem to be clear quite yet. So, even though we have a lot of, we spent a lot of time doing these nitrogen response studies, in the end, it still gives us really only 6, 7, 8 data points to work with. So we certainly do need to expand this work and work with others to figure out how best to assess it. I would say if you're going to do it, start with a 40-pound, assuming a 40-pound credit, and work from there. So especially if the stand's good. If your stand isn't that great, then cut back from there. But might be worth testing out on your farm. So with that, if anyone has any questions down the road, feel free to contact me anytime. mdruark@wis.com, wis.edu, excuse me. All right. Thanks, everyone, and hope you enjoyed it.